Hey, welcome back, ladies and gentlemen. We are going to go over all of Unit 2 today as quickly as possible. So, just for those of us who totally forgot what Unit 2 is, Unit 2 is graphing. Unfortunately, we're not going to go over, how to graph. I know that would make sense, right? Unfortunately. Barton, you didn't teach me how to graph. Don't trip. We'll learn stuff. We'll review stuff about graphing. Some important stuff, some useful stuff, but if you want to learn the hard, crazy stuff, you gotta go do that on your own. You gotta go find a book, maybe. God forbid, a book. Read one of those. But all right, let's get started though. Let's go check out graphing. So the first thing I want to talk about, this is Unit 2, Lesson 1. What are the different types of graphs that you're gonna see around, out and about in the wild? What kind of graphs can you catch near Pallet Town? So, first one you ever learn, this is like baby's first graph, is a linear graph. This thing's a straight line, implied arrows at the end. This thing is called linear. It's going to look like y equals mx plus b. And there you go. That's a linear graph. The only questions that are in that section are, what type of graph is this? And then you say linear. And then that's apparently college level knowledge. The next type, these are your parabolas. The fancy schmancy name for them. Oh, that got lazy at the end. Do you see how perfect this side is? And then bleh. This is a parabola. These are y equals x squared type graphs. The fancy name is a quadratic. You'll see them interchangeably used. Usually quadratic is what people say when they're talking about the function itself. And then when they mean the shape of this graph, they say parabolic. So it's kind of know your context. Right? It's the difference between hot food and spicy food, right? You can sort of use them interchangeably, but one of them is for one thing and one of them is for a different thing. But okay. Then we've got our absolute values. They just look like big V's. They're nice and pointy. These are linear. They go up forever. Absolute value. This is like y equals the absolute value of x. That's what those graphs look like. They could be flipped over. You could have an upside down V if you just put a negative outside the absolute value sign. Same thing with parabolas. They could also be upside down U's if you make the squared term negative. Cool. The other types of graphs that we have gone over already that you should know all about are exponential and logarithmic. Exponentials are when you have like y equals some number, right? This one's e because it's my favorite number, but it could be 2 to the power of x, it could be 3 to the power x, whatever base. As long as the x is an exponent on it, you're going to get a graph that looks like this. Remember, there's an asymptote here. It's an invisible line that you're not going to cross. And then this side continues up forever. Logarithmic is the inverse of an exponential. This is like y equals log base 2 of x, something like that. This, because it's the inverse of an exponential, of course has a vertical asymptote here. On one side, it will come down, follow very close to the asymptote, and the other side will diverge and go up to infinity. My math teacher, God bless her soul, Miss Stefan, right? She was my high school math teacher. She used to call these Loch Ness monsters. And let me show you my beautiful drawing here. She said, this is like the water. Let me get the blue color. We got the water right here. These are waves. Okay. And this thing's like a Loch Ness monster. It comes up. Let's make it angry because it's a monster, right? Comes down. Put some flippers on that bad boy. Hang on. Check this out. This is pretty good. Oh, shucks. I erased too much. Is this going to work? That'll work. Perfect. There we go. Look at this thing. Loch Ness monster. Anyway, yeah, I digress. Either way, right? It kind of looks like a Loch Ness monster coming up out out of the water. That's how I remember that this thing's a log graph. I don't know. Miss Stefan meant well, but no, I'm not even gonna. No, but she was a great teacher. It is 10 out of 10. I love that class. All right. Cool. So those are the different types of graphs. Of course, this is not a complete list of graphs. There are other graphs that exist. You want to see some cool ones? We're going to learn about these wonderful things called sine and cosine graphs later. They look like this. They just wave forever in both directions. They keep going like this. We'll see these later. This is a sine graph. Watch this. Now it's a cosine graph. That'll be way funnier when we actually learn it. But we'll see these cool waves later in class. There are other cool graphs that you'll learn once you get to college and stuff. There's the logistical growth graph, which looks like this. And it has an asymptote there. And it has an asymptote there. And it kind of gets squeezed in between them. This is how populations grow. But yeah, there's a bunch of graphs. My recommendation is if you ever come across a function in the wild and you don't know what it looks like. So let's say you get like y equals the absolute value of x squared minus 3 plus 2 or something like that. Just go find a graphing calculator and type that in and then look at it. You live in an era where you don't actually have to know how to, okay, don't make me eat my own words, but you can look at graphs of pretty much anything you want by typing them in using a computer. You should know you should have an idea of what they look like beforehand, right? You guys should be like this. Wait, how do you make a Right, sitting there like, All right, you should have an idea of what this thing looks like. You guys want a baseball hat? Cool. That's you guys. You should have an idea of what this thing looks like. But if you don't, no one's going to make fun of you. No one, I might make fun of you. But you're going to come across stuff that you don't know. Type it into a calculator and just look at it. Cool. You should know these 5 for right now. Linear, straight lines, quadratics or parabolas are parabolas, absolute values are v's, exponentials look like that thing, and the log Ness monster, of course. You should be able to recognize these and go, oh, that looks kind of like an exponential, because that'll give you a place to start. So there's the different types of graphs you're going to see. Carrying right along. In Unit 2, we also learned how to read graphs. This is as straightforward as it could possibly be. Reading graphs, it says find the following values. Normally, we talk about f of x. So these numbers right here are x values. So all you have to do to read a graph is go sideways along the x-axis to that number, and then go up or down until you hit the graph, and then ask yourself, how high am I? Right, and this is, right, I can see every single kid. You're like, I'm a Barton fan, right? And you're like, I'm 420.69 high. You're a degenerate. Don't ever say that to me again. But let's do some examples. So if we're at f of 0, go to 0 on the x-axis, go straight up until you run in the graph, and then how high are you? You're 6 high. Cool. F of 2, go sideways to 2, I'm at 0. Ta-da. 3, oh, I'm back at 0 again. Incredible. F of 5, oh, Barton, there's no 5. This is where you use your power of inference. So here's 4, here's 6, 5 is halfway in the middle of that. So there's 5. Go all the way up, you're back at 6. All right, so that's how you read graphs. Go to the x value, go straight up or down, and then ask, how high am I? All right, domain and range. This is where things get a little sideways on us. This is where you, like, this is you guys learning to drive. This is you guys learning how to drive stick, right? Shifting. And this one is where you guys learn to drift. So we're going to learn to drift real quick. So we want to know what is the domain and what is the range of this graph. So we need to recall all the wonderful information that your math teacher taught you. Domain is asking how far left do you go and how far right do you go. Range is asking you how far, whoops, back up, hold up. I drifted too fast, you guys. How far down do you go? How far up do you go? All right. So we're going to answer these using this piecewise graph. It's piecewise because it's made out of two different functions. Here's your first function. Here's your second function. That's what piecewise means. It means you say something like y equals this thing when x is less than 0, and this other thing, come on, what are you doing? When x is greater than 2, or something like that, right? So it's piecewise because it's multiple things. This is one section, and then this is a different lesson, but I jammed them together because you guys are geniuses. So we want to know our domain and our range. So domain is left and right. Always start on the negative side. So we look at the negative, and we want to know how far left does this go. And there's an implied arrow here. Remember that conversation we had? If you're looking at a picture of something and you don't see the legs, you don't go, oh no, it's a family of legless humans. What horrible tragedy happened to this family where they're all cut in half? How did they all live? No, you're not that ignorant of the way pictures work. You understand that hidden below here, they have spider legs, right? Everyone's got their spider legs underneath. You just can't see them because it's a picture and the spider legs got cut off, you know? So we understand, oops, go forward. I didn't mean to delete all, oh no, it's a mess. We understand that this has an arrow here and it just got cut off because you can't show infinity things on a finite plane, right? So how far left does this go? Because there is an arrow here, that implies that we go left forever. Left forever would be negative infinity. So our domain will start at negative infinity, and it gets a parenthesis because you can never get to infinity. Just so this is interesting, let's put a closed circle there and an open circle here, just to make it fun. That's not fun, Barton. Don't complain. All right, so this goes from negative infinity. Domain is left and right. I don't care how high this is. Cover up the y-axis and ignore it. You don't get to know how high up it is. How far over is it? Over, sideways. Look at x. So we go over until we get to 0 on the x-axis. So we put a 0. Because there is a closed dot here, we put a bracket because the 0 is included. All right. Now, that's not the only chunk of graph that we have. We also have this red chunk over here. So to add more to our domain, to include this chunk here, we need to put a union to show that we're including it and connecting it. This is the math symbol for and. Now, where does this one start? How far left does this go? This goes to 2, but because it's got an open circle, it's not quite 2. It's like 2 point, and then infinite amounts of zeros, and then a 1, right? But not quite 2. It's barely not 2. So we put a parenthesis to show that we don't get to the 2, and then this thing continues to the right forever, because there's an implied arrow, because we know people have spider legs, and this goes to infinity. All right. Now for range, now we want to know up and down. So now ignore the x-axis. We don't give a hoot about the x-axis. We want to know how far up and down stuff goes. So always start on the negative side. Here's negative infinity. So we've got an arrow pointing down. This thing goes down forever to negative infinity. And it goes up to, this is negative 1. It's not labeled, but it's negative 1. And we put a bracket because this is a closed dot. Okay. Union. Now we're going up, right? This is not where we start because, again, we're going up and down. So where's the lowest point on this red piece of graph? It's not this end here. It's this spot right there. So this spot, we want to know the height. It's at 0. And because it doesn't have that implied open circle, it doesn't have an open circle. There's no such thing as an implied open circle. If they want an open circle, they have to draw it. Because there's not an open circle here that's visible and super obvious, it's a closed circle. So we get to include this point. So bracket for inclusion, 0. And now how far up does this red piece go? Well, over here it only goes to like 0.25 or whatever that is. But it doesn't matter because there's another spot over here that goes higher. And this is continuous. There's no holes in this. So just take the continuous side. This little side doesn't matter. You don't say, we only go to 0.25, because no, you don't. Look at all this other stuff that goes above 0.25. So we go from 0, and then this thing just goes up to an arrow forever. So it goes up to infinity. Parenthesis, because you can't get to infinity. All right. Last thing we need to talk about from Unit 2 are transformations. So for your transformations, let's just talk about the way transformations work in general. And this, let's put like a little star here. We didn't talk about this back in Unit 2, but now you're aware of them. This equation is not for ellipses nor hyperbolas. Okay. Because these two things are a little weird because they're not functions. If you graph them, ellipses are like that and they don't pass our vertical line test. So it's not a function. So it doesn't really make sense to write them in this format. So what I'm about to tell you is not 100% true for these two things, but it's good enough for Unit 2. So A, whoops, excuse me. Oh, shucks. Let's just try again. All right. Let's just try again, I said. A is going to do two things. It can stretch or shrink our graph. And it will do that by being a number. You're going to say, isn't everything a number? And what I mean by that is the value of A, like if it's 2 or -3 or 8 or 3.1415926 ... The value of this, ignore the sign, just the number itself will determine how much it's stretched or shrunk. And you're going to say, but Barton, what about the negative? Why are we ignoring it? Okay, breathe, kid. We're getting there. The other thing that A can do is if it is negative, it can flip the graph. So this A value is in charge of two things. It can flip stuff upside down, or it can stretch it or make it short and fat. All right. We know that our H value is our horizontal shift. Horizontal shift. And remember the sign is reversed, meaning if this says x minus 3, you're actually going in the positive 3. Okay. That's because it's inside a math operation. This little n here just means it could be any exponent you feel like. It could be a 2, it could be a 1/2, it could be whatever. It's just a placeholder, don't worry about it. Because the h is inside this math operation, that's what reverses it. Whoops, that was maybe a little too enthusiastic on my part. And that's all I want to say on that. All right. And then K, you guessed it, is the vertical shift. There we go. And this moves it up or down. If K says +3, then you go in the positive 3 direction. K is not reversed because it's just floating out there plus K by itself. If it were inside a set of parentheses, like ellipses or hyperbolas that we learned in Unit 7, I think, where you have like x minus h squared over a squared plus y minus k squared over b squared equals 1. Because this k is inside this math operation, this k is reversed for ellipses, but this k is not being operated on by something else, so it just does exactly what it says. Okay, is that difference clear? If it's not, make sure you leave a comment below and tell me what you, just kidding, comments are disabled, go tell me in the WebEx. All right, so that's what these do. This flips stuff and stretches it, this moves stuff left or right, this moves stuff up or down. This math operation here doesn't matter. We could have a square root, we could have an absolute value, we could have it be squared. Yeah, you could have all kinds of weird stuff. The important thing is kind of the format. That's what you want to be worried about. Don't trip about square roots and all that stuff. They're all the same. So let's go look at a couple of examples, shall we? So let's just write out, how do I get from this thing to this thing by doing the transformations? So right here, this f of x is going to go up 5 from the origin. Good, because this k value right here is plus 5. It's not going to move sideways because we don't have an h value. So this thing is going to be 1, 2, 3, 4, 5. It's going to look like that. All right. This one is going to go right 2, because right is the positive direction, and we have to switch the sign for h, and up 2. So we want to know what's the difference between this and this. Well, this one didn't move right, and this one moved 2 right, so they are 2 apart. So to get from here to here, we need to go right 2. This one is up 5. This one's only up 2. So if we're looking at our axis, 1, 2, 3, 4, 5, comparing this to this one has to go down 3, because to get from 5, you go minus 3, and now you have 2. So we're going to go down 3. Good? All right, next one. This one is going left 3 and down 7. And this one's not doing anything. It's just sitting at the origin. So to get from here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. To get from here back to here, what do you have to do? You have to go right 3 and up 7. Okay, so it's always, how do I get from here to there? I think it really helps if you at least draw out the vertices like I've done there. Making stuff visual always helped me, but you might be way smarter than me and not need that. All right. Here, we're going left 1 and down 7. Here, we're stretching by a factor of 2, going left 1 and down 6. So this one is 1 higher. If this one's down 7 and this one's down 6, this one's 1 up from there. And it's stretched by a factor of 2. So let's write that. So this is going to be stretched by a factor of 2 and up 1. All right, and then last one. These are the exact same thing. This matches this, and the only difference is this minus 3. So what's that minus 3 going to do? It's going to flip it because it's negative. So flip vertically. And then because it's also a different number, this is an invisible 1, this is a 3. Because this number is 3 times as big, let me enunciate. This is going to be 3 times taller, or that's super informal way. We should say, let's do it correctly so that I'm setting a good example for tomorrow's leaders. One more. Stretch by a factor of 3. There you go. Okay. So that's kind of the gist of what we learned in Unit 2. If you are still not super comfortable with graphing, don't worry. You've got homework to practice on. Aren't you fortunate? Aren't you so happy that you live in a developed country where we value your education and we care whether or not you get the necessary skills required to be successful in the 21st century in the competitive worldwide business market? Yeah, me too, kids. All right, have a great one. Let me know if you need any help. I'll be in the WebEx, of course. Until next time, be safe, be happy, tell your parents you love them, stay out of trouble.